So hey everyone, welcome you all to the channel. Now in this video what we're gonna do is we're gonna see how you can upgrade your smart contracts. So let's say you are in a condition or situation where you want to fix some sort of vulnerabilities, you want to make some changes in the logic of your contract, or you might be thinking to make some sort of new features. But as you all know that the blockchains are immutable in nature, so the first thing that would come into your mind is that okay, if I can't make the changes in the previous one, I'll just go and simply deploy a new smart contract. But again, there will be a problem, and it will be that the new version will start all over again with new and empty storages. But let's see a method, which will work on any EVM compatible blockchain, whether you're using Ethereum, whether you're using the Binance Smart Chain, or you're using the Polygon, right? So let's see how it works, and it's basically called a proxy contract using delegate calls, right? How it works is, let's say you're the admin, and what you did was you created a smart contract v1 and deployed it, and for the same you created the proxy. Now proxy is something where all the data will be stored for the smart contract, right? And the user, when he is coming, he will not directly be interacting with this v1. Rather what he will actually be doing is he will be interacting with this proxy, and this proxy will be pointing to v1, right? It's an indirect one, right? Because there will be a fallback function which will call the smart contract v1. Okay, now you made a new business logic, you made some sort of new amendments to it, and now you have the v2 smart contract. So again, same thing will happen, that we will have the user will go and have a talk with the proxy, and now what we are going to do is we are going to make this proxy point to v2 instead of this v1. This is as simple as this sounds, right? This is what we are going to create. Okay, one thing more that I want to make you know is we are going to use the assembly code over here. That's what actually assembly over here is, right? So assembly basically is a low level language that is used to write the code directly in Ethereum virtual machine bytecode. Now assembly can be used in multiple ways, right? It will help you to optimize the gas usage, it will help you to write the code it was not possible to be written in the Solidity, and the best part is that you will be interacting with the EVM directly, right? These are some sort of the best part that you can see with the assembly. Okay, now let's get started. So I'm going to code all the smart contracts in the same file, but whatever suggest you go and deploy different files, and play along with it, experiment with it. Okay, so without wasting any time, let's do it. Okay, let's create this v1 and v2 first, and then we're gonna jump directly into the proxy. Let's not waste the time. Pragma, I'll go with 0.8.0. let's say we're gonna use it. Now I use contract. Okay, let me just have it a bit more space for it, right? Cool. Contract, let's say it is v1. Okay, let's create a function. It's gonna just take the user age as an input, right? Let's say you have to int public age. Cool. Okay, function have, let's say its name is set age. Type we can have it for the new int, and let's have it age, and external. Now we're gonna just have this as in this code age. Cool. Now you as a owner thought, okay, now I don't want one age, I want two ages, right? I don't know why you as a user want it to be done, but let's say this is how you want it. Okay, we did it. Contract v2. So as I said, I want to have two. What I'll do is I will just copy it and paste it over here. What I need more is, let's say it's h1 going to select h2 function set. Okay, now I'll just use this h1 for h1. Have this. Cool. I'll just again go and copy this function. Control C. I'll have Control V. Just tap this over here. Over this, and 2. Cool. Now we are done with coding the contract v1 and v2. Now we have plenty of time for writing the proxy code. Let's just simply directly jump onto it, right? Cool. So we're gonna start writing the proxy contract. Pragma again. Let's 0.8.0. Contract proxy smart contract. Let's say it's the name for it, right? It's totally up to you. right? What do you want to do? Okay, now what we are going to do is we are going to create two constants over here with the name one for the owner slot and one for the smart contract with the business logic, right? And which are used to store the location of the two storage slots in the Ethereum blockchain. Now these slots are used to store the address of the contract owner and the address of the contract that contains the business logic, right? Let's simply code this byte 32. We're gonna use it. We'll make these private. We gonna also have these as constants. Okay, let's say we have owner, right? Owner slot. So when you will deploy it, you will get some address. This is basically that address. Let's say address 1. Cool. Now the next one, as I told you, will be the smart contract with the business logic. Underscore smart contract with business logic. I'll just change it to 2, right? Don't worry, when you're gonna put some sort of address over here, it will automatically be changed, right? Cool. Okay, now let's go on and have our first constructor of this code. So what are the things that I want the constructor to be doing? Constructor. So the basic usage of the constructor will be, right, we want a way to call this owner slot, right? That's the first thing that we're gonna do. And other thing is we want to set the admin, right? Who is going to be the admin? The one who is going to deploy it. So how we get it? We use the msg.symbol, right? Then in the constructor again we will have some sort of assembly code as well. We will have a look at it too. Okay, let's first call this byte32 slot. It's going to be equal to underscore admin. So sorry, my bad. Owner slot. Cool. This is done. Now we want it for the address of the admin, right? I'll just use admin equal to msg.sender. Okay, now it's time for the assembly code. Cool. So what actually is going to be here is we are going to use some sort of cool things called as a storage, right? And there's a keyword called sstore. Now sstore is actually a keyword, right? It will help you to store a value in the storage slot. Now the slot variable, this slot variable will be the index of the storage slot, where the where the actual value will be stored, and this underscore admin is the value that we want to store. Right? So how we're going to write it is, so one thing is that the storage in the Ethereum are actually key value stores, and it is used to store the permanent data onto the blockchain. Now each contract will be assigned only a fixed amount of storage, and it is basically divided into 32 byte long slots. Now this instructor will allow you to store the 32 byte value in a specific storage slot. Okay, let's see how it's gonna write. Store, it will be slot, comma, it will be, as I said, admin, right? Okay, we don't use this for the assembly one, right? Now we're done with the constructor part. Now we're gonna go with creating. Okay, I'm done with it. Function, right? So there will be a function for the admin. Now what we are going to do is what we are going to do over here is we are going to load the value which was stored in a specific slot into the smart contract storage, and we are going to return a value that is the owner variable. Cool. Okay, so it's going to be very simple. Admin. The only new thing is the assembly code, right? Public view. We are going to return some value, and what's that value is address for the owner. Cool. Again, we need byte 32. We need a slot, and what actually the slot is going to be, this owner slot, right? Control C. We will do it Control V. Cool. Now let's directly jump onto the assembly. AWS EMBLY assembly. Okay. For the assembly, we are gonna the owner. We are gonna fetch the value, right? Now there's a function called sload. Now it is actually a low-level EVM opcode, and it will allow the Solidity to read a value from the storage at a specified slot. Now the slot variable that we have written over here, right? It represents the index of the storage slot that contains the value that code wants to read. Now the owner value is used to store the result of the sload function call. Now it is declared as a Solidity variable. and what we use is operator which looks like this, and actually it's same as like an assignment operator, right? It is actually used to assign the result of the sload function, sload function that we have into the variable called owner, right? We have the slot over here. Cool, we're done with this part as well, right? It was quite simple, right? Now what we are left with is a smart contract with logic, right? There's gonna be a function for this, right? So we are gonna use view modifiers and a hell lot of things. So what it actually do is it will retrieve the address of the contract, which actually has the business logic, by reading it from a specific storage slot, and it will return it to the caller. Cool. So let's get started with the function. We have function with, let's say, smart contract with logic. I know it got a bit long, but anyways, don't care about it for currently. View, we're gonna return a value. What's that value is? It's going to be the address, contract with logic. Is it perfectly well? Okay, I just did something wrong over here. Okay, same. We need this byte 32 slot over there, slot, but there's a catch over here. This time we will not use the owner slot, right? What we are going to use is the smart contract with the logic slot, right? So it will create a 32 byte slot variable, and it will be initialized with the value of the constant variable smart contract with logic. Now this is smart contract with logic slot, let me just show you which one I'm talking about. This one, it will actually be the identifier, and it's going to be unique for the specific storage slot that is used to store the address of the contract with the business logic, right? Then we are going to implement the assembly as well. Cool, we've implemented it. Okay, now we just need to go with assembly. I'll just go assembly. Now we are gonna return a value, right? And for returning a value we need a variable. Now let's say we contract with logic. Why is it showing the output? Don't want it. Cool. How we use the operator is this, in this particular fashion, and as load we have the slot. Cool. Done. As simple as this, right? So what actually is happening over here, right? We have this view modifier over here. So this view is not gonna make some sort of changes into the state of the smart contract, but only it will read the values, right? Now we have this function. It's going to return the address, and it will hold the value of the contract address written by the function. Now the function is having a byte 32 slot variable, and it is initializing with the value with a smart contract with business logic slot. Now it's actually a unique identifier, and it's going to for a specific storage slot, and it is used to store the address of the contract with the business logic. Now this assembly block will be used just to read the value of the storage slot identified by the slot. Now specifically the sload function is called with the slot as an argument, right? But for this one, we are using it such way. Now the retrieved address to the assigned with the contract with logic variable with this particular thing, right? As simple as that. Cool. So we are done with it. What we are left out with is a upgrade function, right? We will have a function upgrade. Let's write it down. How is gonna to be used? So what actually it will do is it will be used to change the address of the contract that is containing the business logic by storing the new address in a specific storage slot. Now it will allow the contract to be upgraded without changing its overall structure, and in this particular fashion we are maintaining the compatibility with existing code that it's going to interact with, right? So let's simply write it. We are also going to need some sort of parameter, and what will be that parameter? It will be the address of the new contract, right? New contract. I wanted to be some external. Cool, we are done with it. Okay, now first thing first, we want this upgrade to be done only by the owner, right? It's not like anyone is coming and he or she can make the changes. Cool. So what we are gonna do is we are gonna first have a condition that msg dot sender should be equal to admin. We've already written the code for the admin. This one, line number 44, line number 44, it's there. Okay, if it's not, you are not admin. Cool. Again, now we will have the byte 32 slot variable, and again we are going to give it where it is being stored is this one. Cool, we are done with it. Now comes the part with the assembly code, right? Assembly. Okay, so we have to store it, right? We have already seen what we use for the storages, that is called the s store, right? S store. At the targeted address slot, we are going to store this new contract address. Cool, as simple as that. Okay, let's just again recheck what actually this function is doing. Okay, now it is upgrading by changing the address of the contract with the business logic. Now the function is going to first of all, verify that the sender of the transaction is the admin or the owner or not, right? Let's say how it's going to do is it's going to just check out that msg.sender is it equal to the admin, right? Now if the sender is owner, right, it's convinced, okay, he's the owner. Now the function will create a byte 32 variable called a slot, and it will initialize it with the value of the constant variable smart contract with the business logic slot, right? Now this constant is unique identifier for a specific storage slot that is used to store the address of the contract with the business logic. Now this assembly block, it will be used to upgrade the value of the smart contract slot identified by the slot. Now specifically speaking, the store function, right, is called with the slot and new contract as an argument to store the new address of the contract with the business logic in the specified store slot. I just made a small mistake over here. It's like underscore. I didn't mention the underscore over here. Cool. Now I'm done with it. Now come the most interesting part and the best part that I personally feel about this contract. It's the fallback condition. Okay. We'll have it external. We're gonna make it a payable function, right? Cool, you're done with it. As soon as we get into it, we're gonna start with our assembly code. Cool. Okay, let's first talk about what actually this function is gonna do is, right? Through this function, what we're gonna do is we are gonna implement a fallback function in a smart contract, and it's gonna forward all the incoming calls to the another contract that contains the actual business logic that we were talking about over here, right? Pointing to some sort of business logic, right? Now we are going to use assembly to retrieve the address of the contract that contains the business logic from a storage and save it in some sort of temporary memory. Now then we are going to copy the incoming function call from memory to another memory slot, right? How we're going to do is we're going to use keyword called call data, right? Now after that, what we're going to do is this function call is forwarded to contract that contains the business logic using a function, right? We'll see how that function will work, and there will be a function which will execute the function call in the context of the calling contract. Now it means that the state of the calling contract is preserved. Now if the function call is successful, let's say it's successful, right, then the return data is copied from the memory to the output buffer using the another function. We'll write it down, and the data now will be returned to the calling contract using the return function. Now let's say if the function call fails, the function reverts, and we will roll back all the changes that we have made till now. Okay, so without wasting any sort of time, let's simply get started with it. How it's gonna look is, first of all, we need to find a target. Like, what's the target gonna do is okay, wait, so sorry, it's assembly code, right? We'll use this way. Now what we are going to do is we are going to retrieve the address of the smart contract that contains the business logic, right? How we're gonna do it? We'll use sload. Cool. Sload on what? Right? Which is the thing that's gonna contain it, right? It is something that we have the smart contract with the business logic slot. This is the address. This is actually the identifier. Speaking is just address is wrong. It's actually a unique identifier for it. Now we are having a 32 byte variable a smart contract with business logic slot, and it is going to used to as a storage slot, to store the address of the smart contract that will contain the business logic. Now load function will be used to read the value that is being stored, right? Now, so to be quite frankly speaking, it will simply, what will do, it will retrieve the address of the smart contract that contains the business logic, right? Nothing much about it. Then we will have something called call data that I just talked about. Call data. Rather we'll use call data copy. Okay, let's just see it. Right? Let me first tell you what actually the call data is. So call data, basically it is just a special read-only area where the function arguments are stored during a contract's execution. Now this call data copy, it is actually a low-level function, and it is provided by Solidity to copy the data from a call data area to the contract's memory, right? Now how are we gonna write inside it? Okay, so we just need to provide the memory position, right, from where we're gonna start it, right? So how it look like is 0x0 and again a 0x0. What actually 0x0 is, it actually is a hexadecimal value, and it's represent the starting memory position where the data will be copied, and the call data size is a Solidity function, right, that we are gonna write now. That is called the call data size. I hope I'm writing it correct. So right, so this is the call data size function, and it will return the size of the call data in bytes. Now therefore what actually this code is doing, it is copying all the data from the call data area to the memory starting at the position 0x0. As simple as that. I hope you got it, what I meant to say. Now we have now just something a bit technical one. Now we're gonna have a result. Now what we are going to do is, we are going to have a result variable over here, which will have a boolean value to be stored, which will be later used, right? So here actually we are going to create a delegate call, right? Now we have, let me first complete the code and I'll give you understanding about the code, what actually it is doing. This will be written as delegate call. I hope so. This is how we write. So it's called the delegate call. Again, it has some sort of parameters. First of all is the gas, right? So the gas function, it's a function actually, and it is returning the amount of gas available for the current function call. The second argument over here would be the address of the contract that is being called, right? What is that? We have already done this. It's the target. It's the target, right? And then hexadecimal value 0x0 from the beginning of the memory. Now the fourth argument will be the size of the input data being passed to the function, which is call data size. Here we go. And the fourth and the fifth one aren't that important, right? Let's just have it over here, right? So let's just see what actually this line is doing. Now this line of code, is actually making the use of delegate function calls in the Solidity. Now delegate call is a special low level function, and it is going to allow you or a contract to call under the contracts function and execute the code of that function within the context of the calling contract. Now it passes control to the callee and allows it to modify the state of the calling contract. So for this, the delegate call is being used to call a function in another contract whose address is actually stored in the target variable. Now the gas function is returning the amount of gas available. Now the other that you have the target, it is actually a smart contract you are referring to. Then another we have the 0x0, it is actually the beginning of the memory, right? And and these last two, right, arguments, these are the memory location where the output data from the function will be stored. In this case, what we are going to do is the output data is not being used, so the values are 0x0 and 0. So I hope you got what this line of code means over here. Now we have the final one, right? Not the final actually. There we are left with two more items, right? So one of them is the return. Okay. So what we are going to do is, it is in the context of the fallback function that this code, right, that we are writing now, it is used to copy the return data of the function call, which is to be made to the contract, the business logic, and after the delegate call function is going to execute. Now let's first of all write it down. How it will return data copy. Wait, it's not this much. It's a complete return data copy. I just made a small mistake over there. 0x0, 0x0, comma return data size. I hope so. I'm going cool. Okay, so it is the assembly line code and it copies the return data of the function into the memory. Now, this when the function is called, now it can return a value or revert with an error. Right now, the return data copy function will copy the return data into the memory so that it can be processed by calling the contract. Now 0x0 is the argument that specifies the memory location where the data should be stored. Now return data size, it will return the size of the return data, as the name suggests. Cool. So this code is basically using to copy the return data of the function call that is to be made to the another contract, and it will contain the business logic after the delegate call function will execute, right? It's kind of simple. And we are now left out with the last, right? It's going to be a switch statement. Now why a switch statement? Now this switch statement will be used to handle the results of the delegate function call that we are making. Let's say the delegate call fails, right? It will return a value 0. Now the switch kill will execute the case 0 block and it will call revert. Now this revert transaction and then return any unused cache back to the sender. Now 0 parameters passed to the revert indicate that no data should be returned as a part of the error message. Cool. Now if the delegate call is successful, right, it will return a non-zero value for that. Now switch statement will execute a default block. For that, what we are going to give the case is that the function will return the data stored by the delegate call function and using the return, and this will return the data starting from memory address 0x0 as we already seen, and with the length of return data size. Cool. I hope you got what actually it's going to do is return. So sorry, we were talking about the switch case. Switch result. First of all, we're going to give a case 0. For this case 0, what I talked about was if it's going to fail, we are going to call a revert, right? So revert will give a value of 0, 0, and for the default we have, let's say we get a non-zero value, right? So we're gonna have this one. So what actually is going to be happening over here, it will be a return value. We will return something, and what actually that's gonna be, we have 0, comma, wait, just made a mistake, 0, comma, return data size, return data size. So this is how actually it looks. I hope you got what actually was here. So the main motive of this video was to just show you how this all works, what actually is happening over here and each and everything, right? It's kind of simple contract, simple code. What I would suggest you what to do next is just go on and try to experiment with it, play with it. There are a lot of use cases that you would find in the near future about it. There are more than this way, right? That you can upgrade your smart contracts. There are multiple ways, but this one was one of the simplest ways that you can do it, and I hope you got it. If not, I would suggest you can go through the Ethereum documentation and figure it out. Okay, what is this doing, right? Try to figure it out, play with it. The more you will play with it, the more you will understand for your future, right? So thank you, and just stay motivated and keep coding. Bye.